I am going to present the command line interface of Avidian SafeKit, which includes the configuration of the cluster, the configuration of modules, and the monitoring and control of these modules. Let's start with an overview. As shown in the table on the right, all commands are prefixed by SafeKit followed by arguments. The SafeKit command is available on Windows in the C drive and the /SafeKit directory. On Linux, the SafeKit command is found in the /opt/SafeKit directory. On Windows, the system account, administrators, and safe web server can execute SafeKit commands. On Linux, the root user and the SafeKit user, the user under which the safe web server runs, can execute SafeKit commands. SafeKit provides powerful command line administration, enabling an administrator to manage the cluster efficiently through a command prompt or a shell. Additionally, the command line can be useful for automating configuration and startup processes via scripts. The interface is rich and simplifies the process of configuring the cluster globally on all nodes, as well as deploying various modules and manage their starting, stopping, and monitoring. Let's now examine how to configure the cluster. In the next slides, we will explain the 3 steps of the cluster configuration process. First, edit the configuration on Node 1. Second, apply the configuration on Node 1 and Node 2. Third, verify the results. Let's start with the editing of the cluster configuration. Begin by logging in as an administrator or root user on Node 1. This will give you the necessary permissions to edit the cluster.xml file. Open a PowerShell, a shell, or any preferred command line interface. Navigate to the var/cluster directory of SafeKit and edit the cluster.xml file on Node 1. In the cluster.xml example, you can see the definition of 2 LANs or local area networks between 2 nodes. The first LAN is named default, and the second one is named private. The IP addresses of both nodes on each LAN are provided. By default, there is a single LAN. However, a second LAN can be useful if you wish to set up a dedicated replication network on a private network. Let's take a closer look at the essential configuration of the cluster.xml file. This configuration defines 2 key elements: the logical name of the LAN and the logical name of the nodes, along with their IP addresses or DNS names. The logical name of the LANs will be referenced when configuring modules, for example, to define where to pass heartbeats in the replication flow. The logical names of the nodes will be displayed in the console, used in the distributed commands and in the SafeKit framework to identify the nodes. For the address field, it is advisable to use IP addresses to ensure resilience against DNS failures. Now let's go to the second step, which consists of applying the cluster configuration on all nodes. Let's begin by changing the directory to the root directory of SafeKit on Node 1, where the SafeKit command is located. Then, check the configuration without applying it. This can be done using the SafeKit cluster confcheck command. This command ensures that the local cluster.xml file is correct and ready to be applied. Next, we can apply the configuration on Node 1. Use the SafeKit cluster config command. This step will configure the cluster on Node 1 and create a new cryptographic key for secure communication between cluster nodes. Once the configuration is applied on Node 1, we need to export it to all nodes. This can be achieved with the command safekit-h*-g. The -h* option runs the command on all nodes defined in the cluster.xml file. This last step will apply and export the cluster configuration and the cryptographic key to all nodes. Let's finish with the third step, which consists of checking the result. To do this, use the SafeKit cluster confinfo command applied to all nodes with the -h*. It is important that the signatures are the same on all nodes. Otherwise, the cluster will not work properly. You can also check the license keys on all nodes with the SafeKit level command applied to all nodes with the -h* option. Let's now consider the configuration of a module. In the next slides, we will explain a scenario with 6 steps. In step 1, we will install a module on Node 1. In step 2, we will configure the module on Node 1. In step 3, we will start and stop the module on Node 1. In step 4, we will install and configure the module on Node 2 from Node 1. In step 5, we will start the module on Node 1 and Node 2. In step 6, we will stop the module on node 1 and node 2. Let's start with the first step of our scenario, which involves installing the module on node 1. Firstly, log in as an administrator or root user on node 1. This will give you the necessary permissions to execute the safekit command. Secondly, open a PowerShell, a shell, or any other command line interface that you are comfortable with. Thirdly, navigate to the root directory of safekit where the safekit command is located. Fourthly, with the safekit module install command, install a mirror module named AM from the generic mirror.safe template. Instead of AM, you can choose the name that best suits you to identify your module. Fifthly, alternatively, install a farm module named AM from the generic farm.safe template. Sixthly, the module is installed on node 1 in the modules directory under a subdirectory named AM, the parameter given during the installation command. Let's move on to step 2 of our scenario, which involves configuring the module on node 1. Firstly, edit the module XML configuration file to set parameters such as heartbeats and virtual IP address. This can be done by editing the userconfig.xml file located in the modules directory. Secondly, you will find the module scripts, also located in the modules directory, which contain the start and stop command for the application. These scripts should not be changed in most cases, as they are already pre-configured either to restart services defined in userconfig.xml or to reboot the virtual machine, also defined in the userconfig.xml file for the Hyper-V or KVM modules. For a mirror module, the scripts are named startprim and stopprim. The startprim script will be executed only on the primary node in the mirror module. For a farm module, the scripts are named startboth and stopboth. The startboth script will be executed on all nodes of the farm module. Thirdly, manage encryption of the module's internal communications. This is optional, but encrypting communications of a module like heartbeats or replication is better. To enable encryption with a new cryptographic key, use the safekit module genkey command. To disable encryption, use the safekit module delkey command. You need to generate the key only once and not at each configuration. You can also use the genkey command to regenerate new keys. Fourthly, apply the configuration locally using the safekit config command. This step should be repeated every time the userconfig.xml scripts or keys are changed. Remember to stop the module before configuring. Let's proceed to step 3 of our scenario, which involves starting and stopping the module on node 1. Firstly, start the module using the appropriate command. For a mirror module, use the safekit prim command on the first startup to force the start as primary of the node with the up-to-date replicated directories. The other node, upon its own startup, will resynchronize its data from the primary node before becoming secondary. For subsequent startups, use the safekit start command because safekit remembers the node with the up-to-date data. For a farm module, use the safekit start command. Secondly, optionally, you can wait for the startup to complete by using the safekit waitstart command. Thirdly, stop the module with the safekit stop command. Fourthly, optionally, you can wait for the stop to complete by using the safekit waitstop command. Let's move on to step 4 of our scenario, which involves installing and configuring the module on node 2 from node 1. Firstly, if not already done, change the firewall rules on both nodes. Refer to the installation slides for detailed instructions. You can also list the ports used by the module by running the safekit module getports command. Secondly, export the module named AM to node 2 using the command safekit-hnode2-eam. The -hnode2 option specifies that the command should be run on node 2 as defined in the cluster.xml file. This step will install and configure the module on node 2, including the cryptographic key. Thirdly, list the cluster state with its installed modules by running the safekit cluster state command. The -h* option specifies that the command should be run on all nodes defined in the cluster.xml file. The output will show the state of modules in the cluster, including node name, module name, mode, ID, date, and signature. It is crucial that the signatures and module IDs are identical on all nodes. Otherwise, the module will not work properly. Let's proceed to step 5 of our scenario, which involves starting the module on both Node 1 and Node 2. Thanks to the -H option, you can start the module on both nodes from a single node, Node 1 in our scenario. You have two options for starting the module. Option 1 is an individual start where you can start the module on each node individually. For a mirror module, start first the node with the most up-to-date data with the safekit prim command. In this example, Node 1 is supposed to be this node. For subsequent startups, use the safekit start command since safekit retains the most up-to-date node. Then start the module on Node 2 with the safekit start command. Node 2 will synchronize data from Node 1 and become secondary. For a FAR module, start the nodes in any order with the safekit start command and by specifying the node name in the -H option. Optionally, you can wait for the startup to complete by using the safekit waitStart command. Option 2 is a global start where you can start the module on both nodes simultaneously. Use the safekit start command. The option -H node 1 node 2 specifies that the command should be run on both node 1 and node 2 as defined in the cluster.xml file. For a mirror module, node 1 will become the primary with the prim state if it has the most up-to-date data, and node 2 will become the secondary with the second state. For a FAR module, both node 1 and node 2 will become active with the up state. Let's move on to step 6 of our scenario, which involves stopping the module on both Node 1 and Node 2. Once again, thanks to the -H option, you can stop the module on both nodes from a single node, Node 1 in our scenario. You have two options for stopping the module. Option 1 is an individual stop, where you can stop the module on each node individually. For a mirror module, stop first the secondary node to avoid an unnecessary failover. In this example, run safekit stop on Node 2 first. Then, run safekit stop on Node 1. For a FAR module, stop the nodes in any order with the safekit stop command and by specifying the node name in the -H option. Optionally, you can wait for the stop to complete by using the safekit waitStop command. Option 2 is a global stop where you can stop the module on both nodes simultaneously. Use the safekit stop command. The option -H node 1 Node 2 specifies that the command should be run on both Node 1 and Node 2, as defined in the cluster.xml file. With a global stop and for a mirror module, you may have an unnecessary failover if Node 1 in the prim state is stopped before Node 2 in the second state. Let's now consider the main commands to control and monitor a module. Here are some essential commands you need to know to control your modules effectively. Note that to get a list of all commands, use the safekit help command. As already discussed in the previous scenario, the safekit start and safekit stop commands start and stop a module. To stop all running modules and wait for their stops, you can use the safekit shutdown command. Some special commands are available for a mirror module, and they must be used in special cases only. To force the module to start as primary even if it does not have the most up-to-date data, the safekit prim command can be used. To force the module to start as secondary, the safekit second command can be used. To force the module to start as secondary with a full resynchronization of replicated directories, the safekit second full sync command can be used. Here are some essential commands you need to know to monitor your modules effectively. To check the safekit version and license, use the safekit level command. To get the state of a module, use the safekit state command. The -V option returns the resource states in addition to the module state. To reduce the output to the synthetic state of a module with an exit code, use the -LQ option. This can be useful for scripting safekit commands. For the logs, you can view the last messages of the module log in real time with the safekit log view command. The -A option displays all messages. To save the module log to a file, use the safekit log save command. Additionally, the outputs of the module script executions are saved in the var/modules directory. A file is created for each script execution with the date of its execution and the script name. Here are other useful commands. For maintenance operations that require stopping the application monitored by safekit, it may be necessary to disable all automatic restarts triggered by safekit. First, for a mirror module, stop the module on the secondary node to avoid a failover on this node. Then, as shown in the first table, Disable the checkers configured inside the module that monitor the application and trigger restarts. Next, disable process monitoring, which also triggers restarts. Finally, disable the automatic startup of the module at boot to ensure that the application integrated into the module will not start at boot with the module startup. Please note that disabling monitoring is permanent, even after a node's reboot. Therefore, you must re-enable everything once the maintenance is completed. As shown in the first table, you have a resource for each case indicating whether it is enabled or disabled. In the system logs, as shown in the second table, you can retrieve SafeKit events in the Windows event log with the getEventLog command and with the journal command on Linux. Thank you for your attention. If you have any questions or need further clarification, please feel free to ask.